Hello, and thank you for joining. As part of the ERA and PigletGen funded project, we have prepared short presentations with the main outputs from experimental trials. Research was done by the monogastric research group at AFBI, and most of the trials were conducted in AFBI pig farm in Hillsborough. For the present seminar, we have Dr. Samuel Ho, who's going to present the third study in a series of three on a topic related to what was his PhD thesis. Sam, go ahead.
Thanks very much, Ramon. As Ramon said, I'm Samuel Ho. I conducted my PhD recently at AFBI Hillsborough, and the main focus of my studies were really to develop intervention strategies tailored to improving low birth weight pig performance. So, quick recap of the previous seminars. The first study went on to commercial farms in Northern Ireland and highlighted the low birth weight pigs as a major problem on our farms in terms of their high level of mortality, their lower weaning weights, and their reduced lifetime performance. Study 2 then determined the impact or the feasibility of an increased sow lactation feed allowance to try and counteract those problems. And it showed that improving the sow feed intake improved milk yield, and that really reduced the mortality of low birth weight litters and improved their weaning weights. But when that nutritional strategy was removed at weaning, the low birth weight pigs reverted back to their compromised state, and they didn't express their maximum growth potential, I felt, during the post-weaning period. So that led to the development of this study, the third and final experiment, which was to combine that high sow lactation feed allowance with a tailored post-weaning feeding regime for low and average birth weight pigs. So, by way of background, in pig production, when animals are weaned, they will first be offered a high specification starter diet, and they are then gradually transitioned to lower specification diets as they grow. However, these diets are tailored for the needs of the average birth weight pig. And as discussed earlier, low birth weight pigs are often associated with an impaired digestive development. And what that means in practice is that these animals are often transitioned onto diets at weaning and in later life before they have really developed sufficiently to utilise the nutrients in the diets that they're being provided with. So what that means is that these low birth weight animals might need to be fed slightly differently if they are to achieve their maximal growth performance. So this slide shows that in this trial, all low birth weight and average birth weight litters were reared by mothers offered the high feed allowance lactation regime as discussed in the previous study. At weaning, these animals were then split into control and treatment groups. Control pigs were fed a standard post-weaning feeding regime, whereas treatment animals did not transition onto the next diet in the regime until their pen average weight had reached a predetermined target threshold recommended by the manufacturer of the diet, who felt that the pigs would then have developed sufficiently to cope with the diet transition at that stage. It was hoped that the low birth weight pigs would remain on the more palatable, higher specification diets for longer, improving their feed intake and their nutrient intake, and allowing them a bit more time for digestive development. And then that would ultimately, we hope, improve their overall growth performance. So looking at the animal profile during diet transition, it was expected that differences in both the age and the live weight of animals at each transition would be more pronounced when comparing low birth weight animals than when comparing average birth weight animals, which were offered either the standard regime or fed on a weight basis. And results are in agreement with this premise. We can see here that there was no significant difference in the weight of average birth weight animals at the majority of their dietary transition, regardless of whether they were fed a standard regime or on a weight basis. However, low birth weight animals offered the feed to weight regime were significantly heavier than low birth weight animals offered a standard regime at each dietary transition. And interestingly, actually, the weight of the low birth weight pigs which were fed on a weight basis matched the weight of the average birth weight pigs following a standard regime at many of these dietary transitions. Now, looking below at the impact of age on dietary transition, feeding regime had no effect on the age of average birth weight pigs in 4 of the 5 diet changes. However, the low birth weight pigs, which were fed on a weight basis, were significantly older than all the other treatment groups at each dietary transition. So to summarise here, whether fed on a weight basis or fed a standard regime, average birthweight pigs were generally the same weight and the same age at each transition. But low birthweight pigs, which were fed on a weight basis, were significantly heavier and older than at each diet transition compared to those fed a standard regime. So we now move on to look at these differences and how they impacted on the animal performance. So firstly, just comparing the low birth weight and the average birth weight pigs in general. Irrespective of treatment, low birth weight pigs exhibited a significantly poorer average daily gain compared to those of an average birth weight pig at all stages throughout the trial. Although birth weight had no overall effect on animal relative growth between weeks 4 and 10, animals in the low birth weight pens recorded a greater relative growth between weeks 10 and 17. The average daily feed intake recorded by pigs in low birth weight pens was significantly lower than that of average birth weight pens at each stage of production. So whilst the struggle to adapt post-weaning diets is common for all weight categories of pigs, it is often most pronounced in low birth weight animals as discussed in the previous studies. And again, that is supported by findings from this study, where the low birth weight pigs recorded a 71 gram per day lower average daily feed intake than average birth weight pigs during weeks 4 to week 10. Feed conversion ratio didn't differ between low and average birth weight pigs except between weeks 10 and 17, where the low birth weight pigs actually recorded a superior feed conversion ratio. Now, this overall effect of feed conversion would support a growing body of literature now which shows feeding efficiency generally doesn't differ between animals exhibiting a low or average birth weight during that post-weaning period. And that's because a reduced average daily gain of low birth weight animals is often offset by a lower feed intake. Now moving on to look at the effect of these parameters, how they were affected by feeding regime. Between weeks 4 and 10, animals fed on a weight basis recorded a greater average daily gain, a greater relative growth, and a greater average daily feed intake than those offered a standard regime. However, feeding regime had no effect on those parameters from weeks 10 through to slaughter. And finally, FCR was not affected by feeding regime during weeks 4 to 10, or weeks 17 to 23, but was superior where animals fed the standard regime between weeks 10 and week 17. So if we now look on to specifically at the intake and the conversion efficiency of energy and lysine, the average daily intake of energy and lysine for pigs in average birth weight pens was greater than that of pigs in low birth weight pens at each stage of production, and that was just purely a reflection of their greater overall feed intake. However, the energy conversion efficiency was not affected by birth weight at any stage of the trial. Average birth weight pigs recorded a superior lysine conversion efficiency between weeks 4 and 10, but birth weight had no effect on that lysine conversion efficiency during any period from week 10 through to slaughter. Pigs offered the feed to weight regime recorded a greater average daily feed intake between weeks 4 to 10 and weeks 10 to 17. And that was a consequence of the animals fed on a weight basis recording a superior average daily feed intake from weeks 4 to 10, as we saw in the previous slide, as well as these animals being offered the more nutrient-dense starter diets for a longer period than standard-fed pigs. However, it is possible that this contributed to the inferior FCR we saw in animals which were fed on a weight basis between weeks 10 and 17 on the previous slide. Whilst neither feeding category consumed their recommended energy requirements during this period, both animals fed on a weight basis and those fed a standard regime exceeded their recommended lysine intake. However, animals which were fed on a weight basis exceeded that requirement by 2% more than those fed a standard regime. And surplus intake of protein or lysine has previously been shown to reduce that feeding efficiency. So hence, the increased intake of lysine by feed to weight pigs during weeks 10 to 17 in an attempt to meet their energy requirements could have resulted in that poorer feed conversion ratio. The conversion efficiency of both energy and lysine was significantly superior for pens of pigs offered the standard regime between weeks 10 and 17. However, feeding regime had no effect on the conversion efficiency of energy or lysine at any other time period studied in this trial. So really, what does that all mean in practical terms? Well, if we look at how the diet transition and the differing feed intake affected actual live weights, we can see that the average weight of low birth weight pigs was significantly less than that of average birth weight pigs at each stage of production. Again, this can be attributed to the reasons outlined in the first experiment, which included a reduced vitality, a reduced digestive development, a reduced feed intake, and an inferior muscle fibre composition of low birth weight pigs compared to heavier average birth weight pigs. At the same slaughter age, animals of low birth weight recorded a lower carcass weight and kill-out percentage compared to average birth weight pigs. Now that's a fairly standard finding, and it's just down to the greater weight of the average birth weight pigs at slaughter. However, the back fat depth was actually similar between low birth weight and average birth weight pigs at slaughter, and similar findings to that have previously been attributed to the smaller number yet the greater size of myofibrils in lower birth weight pigs. Now the interesting stuff, looking at the effect of feeding regime. Although feeding regime had no effect on pig average weight at week 5, from week 7 to week 23, pigs in pens fed on a weight basis recorded significantly greater live weight than those offered a standard regime. Other studies have shown improvements in live weight gain when fed a superior post-weaning feeding regime have been attributed to an improved FCR. But we saw earlier that this was not the case in this study, as FCR was not improved when these animals were fed on a weight basis. So it can be concluded from the results of this study that the improved weight recorded for average birth weight pigs fed on a weight basis compared to those offered a standard regime was due to their superior feed intake, as well as a superior intake of lysine and energy. And similarly, it's evident that low birth weight pigs also benefited from that improved nutrient intake compared to those offered the standard regime. And that's particularly clear when considering the energy consumption between weeks 4 and 10, where low birth weight pigs, which were fed on a weight basis, were over 3% closer to matching those energy requirements than standard pigs. That's quite a pertinent finding, especially during the immediate post-weaning period, where animals typically do struggle to achieve the required feed intakes, and that is recognised as a growth limiting factor in low birth weight pigs. So improved nutrient intake played a big part for both low birth weight and average birth weight pigs, that's clear. But there may have been a second factor at play for the low birth weight pigs which were fed on a weight basis. It's possible that consuming higher specification starter diet longer for longer, as well as being older and more mature at each dietary transition, might have facilitated improved digestive development and improved growth performance amongst those low birth weight animals offered the feed to weight regime. Feed to weight animals also recorded a greater carcass weight, however, animal kill-out percentage or back fat depth did not differ significantly between pigs which were offered the feed to weight or the standard feeding regime. A subset of animals from this study underwent body composition analysis, and this involved the sedation of these animals and scanning them using a DEXA scanner. And when they recovered from the sedation and scan, they were then reintroduced back into their original pen. The same animals were therefore scanned at 4, 10, and 21 weeks of age. And that's a unique aspect of this study because it allowed the change in the body composition of a single animal population to be accurately quantified over time. And an example output from the DEXA scanner is shown on the right-hand side of the slide there. Again, a fairly busy looking table, but we'll just work through it logically. First, comparing low birth weight and average birth weight pigs. So pigs in the low birth weight grouping exhibited a lower level of total body fat content compared to average birth weight pigs at week 4 and week 10. However, no significant difference was apparent there at week 21. The quantity of total lean and total tissue recorded in low birth weight pigs was significantly lower than that in average birth weight pigs at weeks 4, 10, and 21. Animals of low birth weight exhibited a reduced lean percentage compared to heavier animals at weeks 4 and 10. However, birth weight had no effect on lean percentage at week 21. But on the other hand, the low birth weight animals recorded a greater percentage of fat than average birth weight pigs at weeks 4 and 10, with no difference being apparent at week 21. So at weeks 4 and 10, low birth weight pigs had a greater percentage of fat and a lower percentage of lean compared to average birth weight pigs. And these findings highlight the inferior muscle fibre network in low birth weight pigs, which often means for these animals that surplus energy is diverted into the accumulation of fat. But for both low and average birth weight pigs, the percentage lean content increased progressively by a similar extent from week 4 to week 10 to week 21, and the percentage of fat content decreased progressively to a similar extent from week 4 to week 10 to week 21. And that is a unique finding, as no studies at the time of this study had compared the change in body weight composition of low and average birth weight pigs over time by serially scanning a single animal population. It's interesting when we move on to compare the effect of feeding regime on body composition. Essentially, feeding regime had no effect on any body composition parameters. So the total and the percentage lean, fat, tissue, etc. were all very similar, whether the animals were fed on a weight basis or whether the animals were offered a standard feeding regime. And that's a very important finding in the context of the low birth weight pigs. What it shows is that although the low birth weight pigs in general had a fatter body composition with less lean than average birth weight pigs, that was not exacerbated when the low birth weight animals were fed a more nutrient-rich diet. And this is good because initially there was a concern that the additional weight gained by the low birth weight pigs, which were fed on a weight basis, would take the form of fat, and hence it wouldn't have any economic benefit. But these results show that despite that inferior capacity for lean growth in low birth weight pigs compared to average birth weight counterparts, both the low and average birth weight categories in this study had the capacity to convert that additional nutrient and energy intake provided by the regime which fed them on a weight basis to a greater live weight, and both were also able to convert that to the same percentage lean content to pigs which were fed on a standard basis. So what does that mean in terms of your books? Well, using the slaughter weights recorded in this study, along with the price of each ration at the time of slaughter, and assuming a common slaughter or common kill out percentage of 76%, feeding low birth weight animals on a weight basis increased the profitability by 37 pence per pig. But that actually only translates to an increased industry profitability of £67,000 per year. So, yes, it is financially viable to do this, but for the effort involved, producers probably would want to see a slightly improved profitability here. But for average birth weight pigs, feeding on a weight basis increased the profitability by over £3 per pig. And that would translate to a 2 million increase in industry profitability per year. The only real difference in the feeding regime of average birth weight pigs fed on a weight basis compared to those fed a standard regime was that those fed on a weight basis were offered a greater allowance of the grower diet. However, as you can appreciate, these financial figures are quite dynamic and they're always changing. They're heavily dependent on the current feed price and also the current market price. So they will need to be regularly updated to reflect current market conditions. So to conclude, careful management of post-weaning nutrition can markedly increase the live weight of all animals. And more importantly, low birth weight pigs have the physiological capacity to improve their growth performance when offered a feeding regime tailored to their weight and to their stage of development. No detrimental effects were seen on carcass composition. So when fed on a weight basis, both low birth weight and average birth weight pigs were able to convert their additional live weight gain to an equivalent percentage of lean and fat compared to animals which were fed a standard regime. In other words, body composition was not negatively impacted. And finally, this represents an opportunity commercially to maximise the slaughter rate of all animals. And that really will improve the output and the profitability at farm level. So that's the end of my final presentation, and thanks for listening. And I really would like to take the opportunity to thank both the Department of Agriculture and PigRegen for their sponsorship during these studies, and also to AFBI and the farm staff at AFBI and Queen's University for their help and their advice throughout my studies. Thank you very much.
Thank you, Sam, for your presentation. I have a couple of questions because in your trial, as I guess from the presentation, did you have boars and gills mixed in your pens?
Yes, boars and gills were mixed in the pens. They were balanced, so there was an equal number of boars and gills, and we didn't see any real effect. But I think in future studies it would be of benefit to look a bit closer at the specific impact of these treatments on boars and gills. Potentially it could have most benefit for your boars, especially during the later stage of production, because studies would show that the boars have a greater lean growth capacity, which means that they will have more benefit from being offered more nutrient-rich or higher protein diets for longer during those later production stages. whereas your gilts, which have a lower capacity for lean growth, may be able to achieve the same growth potential or have no benefit when that protein's increased. So it'll save money in terms of the cost of the ration, and it'll also be beneficial for the environment because you're not offering those gilts or female pigs a higher specification ration than really they need. So definitely would be an interesting area for future work.
And then on a practical level, how feasible do you think it would be in a commercial farm to change diets based on body weight of the animals?
Yes, good question. I think that this approach is probably a lot more feasible than other experimental studies for low birth weight pigs because it wasn't conducted on an individual basis. The pens were weighed and the average pen weight calculated. So majority of farms now will have a weigh bridge, and it's just a matter of running the full pen of pigs onto the weigh bridge and then changing the diet once the average weight hits a certain target threshold. And also, once the pigs get used to regularly go into the weigh bridge, it's very fast. They know exactly what they're doing. But I think more to the point is the importance on the economics. I think a farmer will be happy to do that if it pays them to do that, if the economic returns are substantial. And it showed in the economic analysis that whilst the profit margin was slightly smaller for low birth weight pigs, your average birth weight pigs also really benefited from this strategy. It was improving profitability by £2 per pig or £3 per pig. So it really will pay the farmer. It's a bit of an extra labour cost, but it's rewarded financially. So I think the farmers, if they were shown that, then they would be happy to do it.
Yeah, and it's worth considering that also technology is improving and getting cheaper as well. And
Yes.
We have feeders that can measure the weight of the pigs. We have video recording systems that also classify pigs or can estimate the pig's weight just from the body shape, things like that.
Absolutely.
Maybe not now, but in the near future, it might be very feasible and not
absolutely.
that expensive. Yeah. Very interesting. Thank you very much, Sam, and thank you all for joining us on this seminar.
No problem. Thank you.